Let's look at an endpoint maximum problem. Suppose I'm given 4 feet of wire, so I'm given a length of 4 feet, and I need to form a circle and a square. How much should be used for the square and how much for the circle? Well, if I draw my square, and my square has sides of length x, then the perimeter of my square is 4x. If I draw my circle, and my circle has radius r, the perimeter of my circle is 2 pi r. So I know this 4 feet has to include the perimeter of the square plus the perimeter of my circle. I'm going to solve this for r. So this is just 2, I divided out by 2, over pi times 1 minus x. Now, the problem is asking how much should be used for the circle and how much for the square to maximize the area. So my primary equation is going to involve the area of both the circle and the square. So the area of the circle is pi r squared, and the area of the square is x squared. So here's my primary equation, here's my secondary equation. The next step is to solve, so I'm going to plug r in. So my total area, when I plug r in, is, is pi times 2 over pi times 1 minus x squared plus x squared. So now I have it all in terms of x. I'm going to rewrite this as 1 over pi, I'm going to factor this out, times x plus 4, how about pi plus 4, sorry about that, 1 over pi, that's what happens when you factor in your head, times pi plus 4 times x squared minus 8x plus 4. Now the first thing we need to do is find out what would be the domain. So before we go on, let's look at the domain. What would be a maximum value for x? Well, that would be as if the whole thing was a square. So 4 equals 4x, so x equals 1. So my domain will be between 0 and 1 for this function. So now I'm going to come over here. The next I'm going to solve. So dA dx is equal to, now this is 2 times pi plus 4. I have no idea why this is glitching on me. X minus 8 all over pi. Now the only critical number between 0 and 1 is when x is 4 divided by pi plus 4, or about 0.56. So now I need to check my endpoints. The area when x is 0. Now I'm going to go back to my original area equation right up here. Where is it? Oh, it's right there. Sorry. This area, when I plug in x equals 0, I get about 0.004 over pi, or about 1.273. The area at my point 4 over pi plus 4, so I'm going to put in 0.56 because that's easier to write, gives me an area of about 0.56. And then the area when x is 1 gives me 1, actually. Now we were looking for the maximum area, so the largest of this right here. So the max area occurs when the square has x of 0. So the square gets none of it. And all of the wire is used for the circle.